Recording in progress.
Good morning, everyone. Today I'm going to talk about performance comparison of machine learning algorithms for malaria detection using microscopic images. This paper focuses on automated malaria detection by localizing and classifying the infected erythrocytes from healthy ones in low quality blood smear images. Um, in this slide, classical machine learning algorithms were used because conventional algorithms fail to process these low quality images. At the same time, the proposed systems can serve as a helpful medium for technicians to reduce their work and also possibly increment diagnostic accuracy. Now, we're going to talk about the proposed methodology. The dataset contains 2,730 blow smear image with bonding boxes of 50,255 malaria parasites. On the other hand, the trainee dataset used 75% of the label data, and the remaining 25% of the data is used for testing purpose. We can see here in figure 1 the test image of the patient is preprocessed and feature engineered before feeding to the machine learning algorithm. After that, the binary classification algorithm classifies the image patch as the presence or absence of malaria. Furthermore, each 1024 by 768 image, which was labeled as either 0 or 1, was split into nearly 475 overlapping patches. Having this label image patches data set, it was posed the malaria identification task as a binary classification model. In addition, feature engineer is an important step in developing the automatic malaria diagnosis system. First, find a representation of the data set is needed, which result in good performance on detecting blood smears, excluding objects such as leukocytes. Given this label image patches, the malaria detection can be posed a classification problem. I mean, classifying either 0 another diseases or one malaria diseases. Here, several machine learning algorithms were used, such as ABUS or random forest, decision tree, k-nearest neighbors to detecting malaria. As you see here, random forest was very good in detecting malaria with accuracy of 96%. As we mentioned, training data set use 75% of the label data, and the remaining 25% of the data is used for testing purpose. Figure 3 conclude that the detection system for completely automated malaria diagnosis is nearly 5 times greater compared with the human technician. On the other hand, this table 1, show the performance of the different machine learning algorithms. So we can see here the values of accuracy, precision, recall, and F-score. All of 7 classical machine learning algorithms were used. We can see, as we mentioned, random forest overcome every other algorithm, followed by AdaBoost. As a final conclusion, we can say that these methods of detecting the malaria parasites can be useful to help workers in place where there is less number of training laboratory experts and lack of resource. The accuracy of this model assists the laboratory technicians decision making by focusing on the parts of image prone to Plasmodium. So that's all for me. Many thanks for your attention.